We'll talk about evaporation in hydrology in this presentation. So what is the physics of evaporation? The net movement of water away from a surface is known as evaporation. By means of mass transport and diffusion processes, water molecules also return to the evaporating surface. The physics of the evaporation process is based on the process of providing sufficient energy for breaking the bonds between water molecules. The fact of supplying the system with heat causes water molecules to become increasingly movable, which results in increasing in distance between them. What are the factors affecting evaporation and the measurement of different factors for evaporation? The factors that affect the rate of evaporation of liquids are temperature, surface area, wind speed, and humidity. Temperature. Under natural circumstances, the vapor pressure of liquid water is mainly a function of its temperature. Air density of moist air is estimated by atmospheric pressure in kPa and temperature in degrees. Surface area. Conceptual relationships of the evaporative process have been developed for complex surfaces such as plants and soils. Land surface includes evaporation from open water, soil, shallow groundwater, and water stored in vegetation, along with transpiration through plants.
Wind speed. Wind and air turbulence reduce the boundary layer thickness, but there is no turbulent flow in the boundary layer itself. Wind speeds measured at different heights above the soil surface are different. Surface friction tends to slow down wind passing over it. Humidity. The mass of water vapor per unit mass of moist air is called specific humidity and equals the ratio of densities of water vapor and of moist air. What are the available methods or procedures for estimating evaporation from open water? Estimates of evaporation from open water are increasingly required for several environment agency functions, particularly water resources and ecology. These estimates are mainly for water balance studies to support appraisals of application for obstruction licenses in wetlands and still waters management. Pan evaporation. The use of pans of water for measuring evaporation dates back to the 18th century. It is easy to understand their intuitive appeal as they measure open water evaporation in a visible way. However, despite numerous studies, it is very difficult to use data from pans except in specific circumstances.
There are two approaches to estimating the evaporation of a water body from pan measurements: pan coefficients and pan conversions. Pan coefficients are simply the ratio of the water body evaporation to pan evaporation. Numerous coefficients have been reported in the literature, although most apply to the US Class A pan. However, the coefficients are generally specific to the pan type, its location, and the nature of the water body. Pan conversions are achieved by taking the ratio of bulk mass transfer equations of the lake and the pan. E is equal to K times E sub S minus E over E sub P minus E times E sub P, where E is the mean evaporation rate from the water body, E sub P is the mean evaporation rate of the pan, K is an empirical constant, E sub S is the mean saturated vapor pressure of the air at the water surface temperature. E sub P mean saturation vapor pressure at pan surface temperature, and E is the mean vapor pressure of the air at reference height.
For mass balance, the mass balance method of measuring open water evaporation is simple in principle. Evaporation is calculated as the change in volume of water stored and the difference between inflow and outflow. Combination equations. The combination equation, the Penman and Priestley-Taylor equations, the mass transfer and energy budget approaches and eliminated the requirement for surface temperature to obtain his expression for the evaporation in millimeter per day from the open water. Penman subsequently modified this to a form commonly known as Penman-ET, the evaporation rate expected from short well watered vegetation.
The Penman-Monteith equation. This equation is a more general form of combination equation. It was developed to describe the evaporation of water vapor from the substomatal cavities of plants into the atmosphere, where the aerodynamic resistance Ra is the resistance that the water molecules encounter in moving. The heat storage and net energy adverted into the water body needed to be included in the available energy A. Empirical factors. In operational estimates of evaporation, empirical factors to convert evaporation rates measured or estimated for one type of land surface to those of another have been used for some time. Pan-evaporation and empirical factors can be considered as similar methods as they rely on the use of factors, ideally time-varying, to convert standard estimates of evaporation to those of the water body. The difference between the methods is the source of the reference evaporation, measurements from an evaporation pan, or estimates of evaporation calculated using meteorological data.